Very difficult to catch everybody. Anyways, thanks a lot for participating in our Christmas calendar. And we are looking forward very much to your presentation. Thank you.
Thank you, Silvia.
Thank you. So thank you for letting us participate at this and to present KAU and our laboratories. I think we should start with Alexander Kurdyuk, who will talk a lot about the project of GlucuMat, German-Ukrainian project focused on quantum materials. And then Alexander will show some of the labs, and then I'll show some more of the labs and videos of them. So yeah, please, Alexander.
Okay. Hello to all of you. Yes, thank you for joining. Of course, we will see now what we can do. One moment. I think I will start with this, right? And slideshow from beginning. Okay. Can you see the whole screen?
Yes.
Okay, I see on Volodya's that you can. Okay. Okay, so I wanted actually to present a bit. Of course, many of you knows much about this, but anyway, I don't. We were not sure what is the audience for this event. Therefore, something I will repeat. Maybe you find something new in what I'm speaking about. First, of course, the most important for us now it is our joint GlucuMat project, German-Ukrainian Center for Quantum Material Research. Within this project, which, as you know, we won it successfully now, we plan to build in Ukraine Leibniz laboratory, joint laboratory, which will be joint as KAU Academic University and IFW Dresden. And of course, you remember that this was not the first our collaboration. Our collaboration written long ago, but one of the preceding project, one of the best, brightest maybe project was Ukratop, when we have a lot of, I'm not sure that this actually precise numbers. I have here 21 master students, 2 PhD students, and 5 postdocs during these 4 years or even more. And it is for us, it was very important to establish this collaboration. It was very successful. Most of you know about this. And for us, it's also very important new equipment which we get. And I think I do not have now more pictures about first transfer when we got the optical furnace this cryostat with superconducting magnet. But that was already some time ago, before the war, and it was we were very excited to install it, and we are using it now. And the project was really successful here. I think at least looking on all these publications is this mentioning Ukratop, and I now each time mentioning when I'm speaking about our collaboration that very brilliant finishing of this Ukratop could be this Nature paper which you all knows, yeah. And of course, we are very grateful for all Germans, for IFW, for Bernd, and for Jeroen, and for all of you, for Sylvia very much for your help after the war started, and the UKRA Pro program. And actually, now the evolution, we consider this project as an evolution of this previous collaboration. And now I briefly show presentation which I shown here for the when a delegation from BMBF was here, and just mentioning what is about, but also about progress in this year. I will remind that together with this laboratory, we want in some long scale perspective to make it open user access facility, open access user facility, and convert it finally to some independent key laboratory, which is still not the concept of it. It's still under development, but it's considered as important piece, important points of condensation of research in Ukraine in recently. So I mentioned here that we started from the June this project and actually had formed the team which is working here, and we have already some meeting. Actually, there are 2 pages already at IFW and in Kyiv Academic University. And we have some already kickoff meetings, which was the first was coincide with summer school for students, and we have nice lab tours from IFW, and the workshop, the German-Ukrainian workshop on quantum materials, which was this September already. We attended already 5 people from Ukraine traveled in Germany and attended it, and actually already 2 months visits by Volodya and Oleg was already finished. And now it is an important step for us. It is pattern system. This pattern system that was actually, I learned recently that it was on the front page of IFW web page, this system, and now we got it. We already received it, it is delivered, and but we need to put it to the second floor, first floor in German style. So not in the base, or not in the ground floor, but on the first floor. And it takes some efforts, and it is interesting task. Just now they solving it. Therefore, not all of interested people are here present, because they try to go through window, to put it through window to our new lab. I will show you probably. It is here some photos, so we just make a repair. This is not the photo when it was all of the stuff was here. First we removed all the stuff, of course, and then make some repairment, and now it is the floor is perfect already. And maybe it's not, some walls are still not finished, but we will soon you will have the photos of this system here in this lab. And now I wanted to say a bit more about Kyiv Academic University, because this collaboration, why it's so important for us. And Kyiv Academic University, we do it as a continuation of some of our previous organization, but it is most important that it is just a pilot project. And in this project, we want to show to demonstrate to all other our universities, big universities, how actually the most effective from point of view scientists, how education, how scientific education, research education should go. And important thing here that it is education through it's learning by doing research. And I add here internationally because doing research, it is of course important, but to motivate students to go to physics, it is important that this research should be interesting. And interest in research, of course, it depends on the how it is. It should be on the forefront of in the world. And for this, international collaboration is vitally important. And therefore, we are so interested in collaboration, and we are so grateful for the possibility to collaborate, to develop this collaboration with IFW Dresden. And Kiev Academic University now it is just network university. We have seven approximately because it's always changing, and we have seven departments, educational departments. And these departments are located at base research institutes. So there are seven and even more because one department is located at three institutes, and these are large institutes. And department actually you are more familiar with. It is a department called Applied Physics and Nanomaterials, and this department is located at the Institute of Metal Physics here. But that's only one department. We also have, which is related to this project, we also have department at the Institute of Theoretical Physics, Department of Theoretical and Mathematical Physics it's called, I think. And we have some more department, but okay. And here in this, we also have such a center of Kiev Academic University, also located. We have a space here. It is lecture space. It is space for all meeting. We have all this meeting here. It is we giving diplomas here and all different meetings in different years. And this is also space for lectures and for international guests when they arrive, and for different kind of celebrations. And for example, also we have activities trying to make popularization of science and involve very young people. And this is example of some activities with school people. I think I want now to make, why it not? I want to skip it because there are many. And now, oops, sorry, why it doesn't go? Something somehow doesn't react. Sorry, I will try it again. Oops, strange. Doesn't work. This is some example of activities.
The Kyiv Academic University, along with the Department of Marketing and Business Management and the Center for Analytics.
Oh, sorry. Does not work on the whole screen somehow. No. Strange.
The presentations videos.
Okay. Okay. I will go here.
Maybe try just open it in the browser separately, just for that YouTube video, and then.
Maybe if it's not working, I will skip it just. Maybe it needs time. It's difficult to pass through these pages. Okay. Okay, let's continue here. That was very nice presentation. I hope that some other will work about activities here related with the stuff which is called startups, spin-offs. It's startups, yeah, startups, and it is related with one of our activity related with Center of Innovation and with the project of Academ City. And Academ City project, it is the project which also Kyiv Academic University is responsible for it. You can see here, you can recognize it as Berlin Adlershof here, and actually Kyiv, and that was example from which we started to develop here the scientific park, which we call Academ City. And this is Alexander Antoniuk, who is the driver of this idea. And actually, it's not only an example, but the people from Vistov who built the Adlershof, they helped here, and we had a special project to start to boost it. And the idea is to make to make a scientific park based on Academ City. It is called district in Kiev, where many academic research institutes are located. And you see here that here is Institute of Metal Physics, and this is one of several large institutes which are located in this area. And we want to unite it, and we are comparing to Adlershof. The role of university is for Kyiv Academic University, and that was idea why we call it city, because I learned that it is the difference between town and city, that city has a cathedral, and in this sense, university should be a cathedral, like a cathedral, because the idea is that in this scientific park, we should join the research, education, and innovations. And it is very important to have motivated students around to do it. And if we have a look from above on this area, this is the area. Here is the Institute of Metal Physics, Kyiv Academic University. Now we are sitting here, right? Here is the Department of Superconductivity of the institute, where we have these laboratories and where we have research possibilities. But also I wanted to mention about some old project. We in 90s we plan to build a small synchrotron here. And it's interesting that now this idea is revived, not this, but much larger, I would say, on the larger scale. The idea came from Swiss light source, from PSI, from Leonid Rivkin, who born in Odessa, but facing the Russian invasion and also facing the upgrade of the Swiss light source. He came with the idea, why not to build in Ukraine the Eastern European synchrotron, like Swiss light source or even larger. First I was skeptical, but of course, we say that it is very interesting, and we would be very interested in it. And I have several joint meetings with LIPS, League of European Accelerator-Based Light Sources, and they support this idea and decided, or Polish colleagues agreed to be responsible for realization of such this project, and also in general for collaboration with Ukraine. And since then we had many steps already, interesting steps. Not to say that we already plan really to build synchrotron. We plan, but as the first step, Polish colleagues. Marek and Jakub. Marek was director that time, and Jakub director of Solaris now. They suggested to build at Solaris the Ukrainian beamline, and it is already much more serious. I put the slide to say that actual idea of synchrotron is supported, of course, and by National Academy of Science, by Anatoly Zagorodny, and also by our Ministry of Education and Science. And when last time I spoke quite long with Oksana Lisovy about synchrotron, he is quite optimistic, and I became even more optimistic that now it is much more probable to get money for it and to build synchrotron than before the war even. And going back to beamline, beamline is also for us very important. Synchrotron is very nice synchrotron. It is a copy of Max 4. The ring is a copy of Max 4, and I also think that beamline, photo emission beamline, is a copy of beamline at Max 4 maybe. We will check it now. I didn't measure yet, but we plan to in the next run. And this is in the whole experimental hall at beamline will be here. And it is important. Of course, we do not have the funding for this beamline for the whole funding for the beamline, but we have already made several steps. And Luc Pote, we know him very, very well from our previous work at this light source. He already made a case study, and he found actually which undulator from the Swiss light source is appropriate for Solaris. And he found this U19 undulator, which is in vacuum undulator, and it's already ready to be delivered to Solaris. And actually, this beamline will be it is not here yet. Okay. It will be the range of this beamline will be from 2 to 8 kilo electron volts, and it will be X-ray, microscopy, spectroscopy beamline. Of course, we still do not know what will be possibility for end stations, but we already plan undulator and beamline. How it will be. And what is most important that also Luc found get additional funding from Swiss Science Foundation, I think it's called, about 1 million euro. And Daniil Babic, he has found Daniil Babic, who he is from Ukraine, a young guy. He will be responsible for he is paid already from this project, and he will be responsible for making this beamline deliver from the Swiss side, but also, of course, from the Polish side, they also work on it. I will not speak more about it. Just say that we plan to have the first light in 2026. Okay, and strange. I somehow I skip. I did not see the picture. One moment. This is because of this. Sorry. Okay, then I skip it and I leave it to Volodya. Again, it does not work. Sorry. I did not expect that it's not working.
I hope my videos will work because it's main part of the presentation.
Yeah, okay. So the next thing, actually, I wanted to show you some photos and maybe videos for this equipment, yeah, which we get, and some other equipment, but I leave it for Volodya. I just wanted to stop here to say that actually here in between is very nice space. It is green, and we use it often, and for inviting students. I mean the first day of the student, yeah, first day of the student, but also it is called academic open air. So we started before the war, the first academic open air, and we already had 3 of these events, and it is popular, and it is to involve young people to science in general. I will try to run this one. Okay, that's it from my side. Volodya, floor is yours. I got message from Volodya that you didn't hear the sound. Yeah, unfortunately, it was nice music about it, but sorry for that. So I give the floor to Volodya, and he will continue. I think he does not have much, but
Thank you. I need you to stop sharing this. Oh, yes, thank you. Let's try now. Hopefully, this will work with sound and without lags, but like, when I was testing it, it was fine, but you never know.
yeah, it is a old book, but I probably did not switch it on here.
So first of all, do you see the presentation full screen now?
Yes.
Okay. So yeah, welcome again. I'm happy that so many people actually came here. Last time I checked the video cam, and I know that you had Christmas party yesterday. I hope it was nice and you all enjoyed it. So I'll continue talking about KAU. This I probably don't have to turn on again, even though it was without sound. So when you wait 1 second. Yeah. This is the recent Academ Open Air, which was in 2024, just recently.
Academ Open Air
You see the picture nice, and the sound is
це
also on, right?
науково-популярний фестиваль, що відбувся в Києві, об'єднавши науковців, інноваторів,
It was the same location as the one which was shown by Alexander, but just from this year, and also we got a lot of students, we got a lot of guests on it. It's a nice event which popularizes science, brings new students, brings more attention to science.
Міждисциплінарність. Учасники мали
It's
змогу
slowly
ознайомитись із різними
harder to
галузями
do
наук,
during war, but
від фізики та хімії
it's a
до
very nice
біології та соціальних наук. Нетворкінг. Фестиваль став місцем для встановлення нових професійних контактів між студентами, аспірантами та провідними фахівцями. Інновації, презентації стартапів і нових наукових ідей
And also
були важливою
other base
частиною
institutions
програми.
about which Alexander mentioned, they also include Institute of
Учасники вдосконалювали свої
Genetics
знання
and
через
Biomolecular
практичні воркшопи.
Microbiology, and
Популяризація науки.
there
Захід
are
сприяв
also
поширенню
students and a lot
науки
of
серед широкої
employees coming
аудиторії.
there. So it's
Академ Open
also not only
Aid
physics, it becomes kind of
2024 не лише
interdisciplinary, which is
розширив
also
горизонти знань, але й відкрив нові
very
можливості для
cool in
кар'єрного
modern world.
зростання та професійного розвитку молодих науковців.
And this is already in cryogenic department in that building that was shown on the map. This is Alexander Kalenyuk, and he stands near the cryostat, which we received from IFW just a few years ago. It has the most powerful magnet in Ukraine at the moment, as far as I know, 16 Tesla. So,
this is 16 Tesla magnet. This is a big magnetic field. We can measure any sample, no, not so big, it's 2 centimeters by 2 centimeters sample in a big magnetic field. At temperature, room temperature to 2K temperature. We put this cryostat, this superconducting magnet, this cryostat. We put this cryostat back to the floor, and we have insert for sample holder. We can see sample holder with rotation system for different magnetic field direction.
Rotation system is self-made. What we add here to this system?
We have a stepper motor for rotation, for rotate sample, and put different magnetic field direction. And we have VTA system. This is variable temperature system for changing temperature from room to 2K with regulation system. This regulation system, pumping system, and other.
Also, side note, I forgot to give this comment before. We prepared most of this, all of lab demonstrations in the format of video because we were unsure about blackouts and how it will turn out. But actually, luckily, yesterday and today are the rare days where, like, full day we have no blackouts, at least in our region. So another lab in cryogenic department is the one with lithography. It's a small, relatively clean room. Like, it's not a clean room that you have at IFW. It doesn't have that degree of cleanness, but it's sufficient enough for some lithography. And you can see the optical microscope here and the special lithography printer. And here is the video of the process of it in a few stages.
This is our small lithography room. We can see some equipment. This is our maskless projection camera for making lithography with resolution half micron. We can put our sample in this table and move table and make multi-layer sample. You can see This is a computer for this process. Yes. We can control all the etape. We can see mask. We can design this mask on computer by software and put this as mask direct to the sample. And we can control by microscope our lithography. And so we can spinner and hot plate and other chemical for make lithography.
And the stages themselves, first, you apply the photoresist to the sample.
Now we spin photoresist at the sample. The next baking process. This is our hot plate. This homemade hot plate with very precision temperature. And we're going to put this to the projection camera. Yes. The next baking process. This is our design with 3 bridge, and now we put to the focus model and try to set focus, correct focus. Yeah, I think this enough. I think okay. Okay, give it from focus model. Okay. Can filter out. Okay. It's ready.
This is actually the developer which we delivered just after this recent visit to IFW from IFW to KAU. And here you can see the result of that photolithography. Here the size of this bridge is around 4 micrometers. And some other examples on the right of previous works where like the resolution can be seen and the bridges that they can do. And some arts made with copper on silicon small squares. This is the room with thin films growth and new system. Nice to this.
Так, це у нас лабораторія по вирощуванню плівок магнетронним осадженням. Доброго дня.
Доброго дня.
And probably, I think I didn't. Okay. And also, we have our own supplier of liquid helium in the cryogenic department. There is a large part of it which is allocated to liquid gallium station, which has all the equipment needed to get liquid helium. And that's where we get liquid helium from.
Заходимо на криогенну станцію.
Okay, this is cryogenic station, and unfortunately, again, it's not the video which we planned here, but here is our liquefier, and here are compressors, and this is gas holders, and we have helium return system in all our rooms. Therefore, it's a bit cheaper for us than if not to return, right? And now these compressors pump the gas helium to. We have two detenders. They are quite old. It is 1988 the date for this detender when it was produced, but it is still working. And because of this, we have possibility to measure liquid helium.
Sorry, when I think the video stopped a bit. And lastly, I'll say a few words about FSUMA. You all probably know about this new unique type of analyzer, which was developed by Sergei Borisenko and the company Fermiologics, who sells it. So unlike the normal, since I'm specializing in ARPAs, I left it for the last part. And usual ARPAs analyzers, they have the slit, which is like two-dimensional. In this case, you have one-dimensional. I mean, in this case, you have like a hole, which allows you to get instead of the instead of the electronic structure cuts, it allows you to get the Fermi surface immediately. But I'll show pictures later. This is the lab we are setting up in KAU. We needed to renovate the whole room. This is after we took away all the old stuff that was there, and we prepared a chamber for ultra-high vacuum, and this is it already assembled. But analyzer still is not there because we will put it there in the very last moment when we already like launch everything. And also we've got actually with that sputtered system that Alexander was showing. I'll show video a bit later as well with it. With that sputtering system, we also got a helium lamp. So now we have almost all the basics for the system. So there is light source. We have already the spectrometer. We have electronics for this spectrometer, which we still need to set up properly. But essentially, the very base limit for it is here. And these are the examples of spectra which you can get with FSUMA. I think my previous, yeah. This is the examples of spectra, and FSUMA gives immediately the Fermi surface in very high spatial resolution in Kx, Ky. And here you can see examples from different samples, and you can also see that with different temperatures, it shows nice, it differentiates very nice between different temperatures. You can see also the decrease in here. And it even gives you and not only the resolution in momentum space, but in energy space as well. So this is what we will have. What we will have working soon in KAU. And lastly, the video of that sputtering system. Okay, that is it. Unfortunately, some of the slides during one of the last saves they got a bit shuffled and some disappeared, but I showed most of the stuff that I wanted to show. Thank you for coming and for your attention. Maybe you have some questions. Maybe you want to hear more details about some specifics.
Thanks a lot to you both. Yeah, and so if the public has some questions. So I have a question myself. In the examples of Fermi surfaces that you show that can be measured from the FESUMA, they look a little bit distorted. Is this because the sample is not fully aligned, or do you do some treatment to get it like nicely looking?
You mean that they are not symmetrical?
So I suppose, for instance, B should be some kind of hexagon in the ideal case or something.
Yes, but it's quite complex. This all comes through electric lens, and if Sergey is in the room, he can tell you much more about how complex it is. But basically, like any optics, it gives aberrations, and that already like distorts the picture slightly. Plus, like the farther the signal is from the center, and also the crystals are not ideal. There are some defects and other stuff. There are also such thing as matrix elements, which can make parts of the spectra being bright and part of the spectra being like not visible at all. And then you change polarization and it switches like completely to the opposite one. So it's
I think Sergey will not appreciate your explanation in terms of aberrations, but here is clearly that it is not aligned. Sample is not
Not in
aligned.
the gamma point.
and also alignment in the focus.
When it's aligned perfectly, it should be perfect, right?
Yes. But still, even when it's aligned perfectly perfectly in the center, in the focus, you still will not. Actually, yeah, you will get it symmetrical, but it will not be maybe like evenly distributed in terms of intensity. But yeah.
So do we have some questions from the back of the room?
Questions today.
Space party. But thanks a lot, guys, for joining and for showing us. I mean, until we can probably visit you live, it will be a little bit of time yet. So it gives us
Maybe that's a good wish for the next year, that we all go to Ukraine again.
Exactly.
Peace, and giving us a chance to go to Ukraine and to have a
next
look on the labs.
Hopefully.
Yeah, you are welcome to visit, and the springtime is the best time to visit Kiev.
Okay, let's hope for spring. Good.
So thanks a lot. And unfortunately, you cannot join for the cookies and tea and the specialities of the Ukrainian cuisine that we have today, but you will have them at home.
Yeah, I will join locally.
Thanks a lot, and yeah.
Okay, thank you.
I saved up the Stollen from Dresden, so we will have Dresden Stollen as well here.
Thanks a lot.
Thanks.
Thank you.
Thank you. Have a nice holidays.
Yeah. Merry Christmas.